Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this video I'm going to talk a little bit about arrays, continuing on our last video from where we talked about the different variable types and a lot of the scripting language, like really basic stuff. This we're going to go into arrays which are a little more advanced. I will say that this is my second take at this video. The last recording corrupted, which is sad times for me. So I'm hoping this doesn't disrupt the flow into the next video that I already recorded, so this is going to be kind of weird. For me, at least. But anyway, so we have our Unity scene here, and the first thing we're going to want to do is we're going to want to create a new script file. So just like in the last video, we're going to right-click on our scripts folder, and we're going to create a new C# script. I'm going to call this array examples, and I'm going to open it up in MonoDevelop. So once that's all loaded and ready to go, I would like to start by talking about what these two little functions are here. I kind of talked about them a little bit in the previous video, but I didn't talk about what they were and why they do what they do. And I'm hoping that I can kind of talk about that a little bit. So this line up here is a little bit advanced, but basically what it is it's saying that what this is, what array examples is. It is a class, which is I kind of mentioned that a little bit in the last one, which is it's an object. It's a thing that exists in Unity. It's an array examples thing. It's a thing. So that's what this is. It's a public thing, so everything can look at it, and it is a child of it's a child of mono behaviors, of the mono behavior object. So Unity obviously has a bunch of code in it already. It's not just like an empty thing. I mean, it's a program, so you can do stuff to it, and you can do stuff to it. So a mono behavior is a piece of that. It is what all scripts will root to. It's the parent of them. So if you think about things in a parent-child relationship, and as far as like evolution is concerned, like scientific evolution, certain things things will adapt over time. In this instance, the children of the children of mono behavior can do things that mono behavior can't do, and everything that mono behavior can do. And likewise, if you made children of array examples, which is a super advanced thing that we'll talk about way later, then they would be able to do things that array examples and mono behavior could do, but it could do things that neither of those things could do. So it's kind of like it's called inheritance is what it's called. It's parental inheritance. So that's the thing to just know that it exists, but it's not necessarily something that is going to affect your work right now. But that's basically what this line means. Now, everything that extends from mono behavior, everything that is a child of it, has certain functions within it that will automatically be called. Start and update are two of those functions. Another one that is used a lot is awake. I can spell. So awake is called as soon as the object is awake. So it's like start, because start is called the first frame that the object is active. But awake is effectively the same thing, but it is called before start. So it's like a pre-start function. And then start happens, like I said, at the beginning of the object's lifetime. And then update happens at the end, or at the beginning of each frame. So it's kind of like start, but at the beginning of each frame. But on the first frame of the game, awake is called, then start is called, then update is called. In that order, it always. So on an object that is already in the scene. So if you wanted to do something like, say you had an int value of 1, and you said myInt plus plus, myInt plus plus, and myInt plus plus, you would end up with a value of 3 by the first update. So it would be 1, then it would be 2, then it would be 3, then it would be 4. So I guess you'd end up with 4. I keep thinking this is supposed to be 0. Now it'll be 3 on the first update. So anyway, that's kind of how these work, is this one happens, and this one happens, and this one happens. But then the following frame, you would end up with, this would be 3 at the first frame, at the end of the first frame. Then at the end of the second frame, this would be 4, because these two wouldn't run anymore, but this one still would. And then the fifth frame would be what, 1, 2, 3, 4, 5, I guess would be the fifth frame. That's weird. Or second frame would be 5. So that's kind of what those are and why they do what they do. It's because they're monobehavior functions, and there's a list of monobehavior functions that can be found in the script reference for Unity, which again can be found under help once it compiles and figures out what it's doing. Under help, scripting reference. It's either there or it's under the reference manual. I think it might be under both. But either way, they're monobehavior functions, and you can just Google monobehavior Unity functions, and you should be able to find it. Or look up Unity start or Unity update, and you should be able to find them. Like if you look up this exactly, then you should be able to find what you're looking for. Anyway, if you want to look into more monobehavior functions that will automatically happen when you type them out. There's a lot more than this, but this is all we need to talk about for this video. Anyway, jumping headfirst into what I actually wanted to talk about in this video are arrays. So in our last video, we talked about variables like ints. So we had a public int, my int, and it could equal a thing. And then we had floats, and so let's just make a bunch here. So we will do we'll do a float here, and we'll do a string here, and that one can go away. So we had all these different things. That equal different things, like this. The way that we turn these into arrays, because arrays are, think about arrays like a list of something. So if we wanted a list of integers, if we wanted a bunch of them, we just do that. Granted, we can't make it equal to that anymore. So this is a list of integers, and we can say that that's an int array. And this will be a float array if we do that. And this will be a string array if we do that. So now all of these are the array equivalent of their variable. So if we go back to Unity with that, just that, we create a new game object using Control-Shift-N as a refresher if you don't know the hotkey for that yet. We drag and drop the array examples onto it. We end up with actual lists of that type of object. So these are all integers. These are all floats. The size value controls how many of them there are. And yeah, so this is a string 1. This is gobbledygook, and this is going to be string 3. So that's what arrays are. They're just lists. I a lot of the time have told people to think about arrays like a dresser. That analogy works for 90% of the stuff with arrays. So dressers have a series of drawers. Each one of these is a drawer, and we can define how many drawers the dresser has. This one has 3, or this one has 2, or this one has 3, and we can up to 5 if we want. But within that drawer is a thing. So say that you have a dresser for pants, and you have a dresser for shirts, and you have a dresser for like socks and underwear, and that's what these are. This is in a dresser for int, this is a dresser for float, and a dresser for array or strings. So within this dresser, for example, has 3 drawers, and this one and this one have nothing in them. This one has 38, a value of 38 in it. This one has a value of 2 in it as a float. This one has a value of 0.25 in it. This one has a value of 0. So all of these are different slots in the array. It's also worth noting that all of these have like element 0, element 1, element 2. All of those are, you'll notice that it starts on 0. So the third slot of the array is actually the second slot, the second element, because everything starts on 0. I mentioned in the last video that when you're counting in programming languages, everything starts on 0, and that's kind of weird. This is the prime example of that. This is so slot 0 is the first slot, slot 1 is the second, slot 2 is the third, and I know that throws people off a lot of the time when they're starting off in programming, because they want to say, for example, this is how you access a thing, a slot in an array with brackets. Like, you define one up top, but then you put in a number. So this isn't the second slot in the array. This is the third slot in the array, because 0 comes first, then 1, then 2. So you're actually accessing the third slot in the array. Like this. How you'd use something like this, because it's just an int value, because of how we define this. This is an int value. Then it's going to print whatever the second slot of that array is. In this case, it's going to be 0, or well, it's it doesn't exist. If we it does exist. It's going to be this element 2. So 0, 1, 2. It's going to be 2. If this was like this, if this was 2 slots long and we wanted to access the number 2 slot, we would get an error, because it doesn't have a number 2 slot. It only has a 0 and a 1 slot. We would actually get an error that says array index out of range. It is an index out of range exception. So a lot of the time you'll either get this message, or you'll get what's called a null reference exception, which is the object doesn't exist. So whatever you're trying to access just isn't there. But it's like, it depends on what you're doing, but most of the time you'll either get this or that. Either way, if you wanted to read this, by the way, array examples.start. So array examples dot start, because we're doing this in the start function, and it says line 20 or line 12. So line 12 is right here because of this little thing right here. So that's how you read the console errors, by the way, figuring out where things are. It doesn't tell us what the value is that is out of range. It just says that something is out of range. We are using a number that is out of range in the start function on line 12. So somewhere on line 12 is a value that is bad, is basically what it's saying. Likewise, we would also get that error if we did -1, because array lengths can never be -1. You can never have negative drawers in a dresser, for example. You can only have a set of drawers. And whenever we put a negative thing, it tells us that we should always start at 0 and stuff like that. It gives us a warning that's like, hey, something bad's going to happen if you do that, so don't. So yeah, that's basically what arrays are and how you access them. So in a lot of stuff, what we've been doing is something like this. We've been defining a default value. We've been like, this integer is going to equal 0, but these don't actually have anything in them, and when we use them, it starts off empty. Which, by the way that you reset code objects is you can do two things. There's the way you shouldn't do it, which is you can remove it and then add it again. You shouldn't do that. Or you can right click and say reset. Resetting it will so for example, if I put 5 here and then 2 here and then like 12 here, 123 I guess, that's fine. And then I hit reset, it'll just reset it to its default values, which is right at the moment 0. The way that we define a default value for an array is by saying it equals a new int with brackets, and then we use the curly braces like we would for defining a function, like down here. We do an open and a closed, and within here we can define what is inside of it. So we can say, counting down from 10, we'll do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is going to be a 11 slot array. It counts down from 10 to 0. So once we're in here and it finishes compiling, we can right click on it and say reset, and we will have our variables. We'll see that it has a length of 10, even though it only is going from 0 to 10, because 0 included is 11 integers. And we'll say that the element 0 is 10, and the element 10 is 0, and the element 5 is 5. So it's effectively inversing, is what it's doing. But that's how you do a default for a list like this. Likewise, a float array is the same. You just define stuff like that. It's pretty straightforward. Once you figure out what you have to do, it is very, very easy. New string, and then we can say my string 1. Let's see, 2, 3, 4, 5, and 6. So if we reset this, whoa. If we reset this, then we, oh, okay, it says no to that. Oh, okay. So this is a good example. I accidentally put the, I was supposed to make the curly brackets, and I didn't. So, yeah. Because the other way that you can make an int is by, or make a float, or sorry, God. The other way you can make an array is by saying my other int array equals a new int, is by doing something like this. The difference is this comes with default values, and this just comes with 11 slots that are empty. So there's two different ways to do that, and that's what I was attempting to do, was that on accident by not using the curly braces, and it was yelling at me because it couldn't find an int value that it needed inside of there. I was trying to feed it floats and strings, and it didn't understand what was going on. But yeah, so use your curly brackets to do that, and then once we go back into Unity here, those errors should go away. Well, this one should go away too. And then we can reset this, and now we have default values that are exactly what we put in here appearing in here. Hang on just a second. Unity, I clicked the button, and that's not okay. Okay, we're better. So yeah, so that's how you do default values in arrays. Now, likewise, this is only useful, like I said, for default values. You don't want to use this for anything else. So if you had, say, like, because you can change these, right? You can say that, no, this is not going to be 9, this is going to be 52 for whatever reason. And then that doesn't change the value in here, but that does change the value on the object. So if you wanted to print line 1, or, well, print slot 1, then it would come out as 52, not as whatever the value in here is. If you wanted a list of stuff that you could change, but not that easily, so like a list of stuff that is essentially hidden from the editor, you just don't put public in front of it, which by default in C# makes it private. I don't know that there is a... Oh, if I could spell that right. There is a private variable, but I don't think... I've never really used it. I believe if you just don't put it there, it defaults it to that. For example, if you wanted a list of names, you could say this equals a new string list, curly brackets, and you could say, like, Joe... Jeff... Jeremy. So these are a couple names that we could use, and if I save this and go back to Unity, you'll note that that doesn't actually appear in my list at all. It also tells me that it's not used anywhere, but just ignore these for now. That's what the warnings down here are for. But you'll notice that it doesn't actually appear on my object. It's like my 3 arrays are there, but not my names array. So using private variables is a great way to stay organized in here, but also a great way to make sure that this stays the way that it is unless you say otherwise in the code. So a good example is this name list. If we kept going with these names, we could create a crap load more names. But and we can have essentially a random name generator through that, if that makes any sense at all. So anyway, next thing I want to talk about is how to access these things. How do we use names? How do we get anything from that? Well, using our good old debug log command, I'm going to say names names slot 2, and my numlock has disappeared too. So what this is going to do is it's going to look at the second slot in names. Now again, it's going to go 0, 1, 2, so it should print Jeremy whenever we play the game, whenever we start the game. So if we start and we go to the console, it says Jeremy. If we change that to 1, it should print Jeff. Go to the console, Jeff. And if we change it to 0, it should print Joe. And there's Joe. So again, if we put this to a value that doesn't exist, like 3, then we're going to get an error that says the array index is out of range. Which, by the way, this number that we're giving here is the array index. That is the number that it's what it's called. It's called an array index. So, because this is the array and that's the index number. Another interesting way to grab things, which is much more exciting and much more useful, is using the random class. So if you type random with a capital R, you'll see that it turns blue, which means that it's a thing that you can use in scripting. And if you type dot, you'll get everything you can do with random. So a lot of this is interesting. If you've ever played Minecraft, you probably know what a seed is. A random rotation is good. A random value, I believe, is a value from 0 to 1. It's a float value. It's like a random percentage. And there's a bunch of stuff in here that I've never even really used a lot of it. I have used the random rotation, and I have used random range. And random range is what we're going to talk about. If you look here on the right, it says it gives you a float, and it takes in a minimum and a maximum value. So it gives you a value out that is between this and that. And you also see up here in the top right of that little window that this is page 1 of 2, and if you use the arrow keys on your keyboard to go left or right, you'll see that you can go between the different things, and one of them is for float values and one of them is for int values. And there's a really, really interesting thing with range. So if we start using range and we say that we want to generate a random thing between 0 and names.length, which I'll get to that in a minute. For now, let's go ahead and pretend that that's 0 because that's, or 3, because that's the length of names. So this is going to give us a random integer because we fed it integers. We're using integers here, so it's going to give us an integer back. If we wanted floats, we could type f after each one and it would give us a float value. But we don't want that. We want integer values, and I'll explain why in a second. It's going to give us a random, it's either going to give us 0, 1, or 2 back because the high value on the random range is excluded. It's not included, like, I don't know, like the random range for float is. If you get a random range on a float, the high value is included, so it will give you either 0, it'll give you a value between 0 and including 3, up to and including 3. If you do it with an integer, it'll give you 0, 1, or 2. So I don't know why. I have my theories on why they've done this, but I think it's weird and it's not consistent. I wish it wasn't like this, but it is. So if we wanted to get a random name from this list, what we would do is we want to debug log a names, and then we want to open up the slot. We want to say random.range. Open up the parentheses because it's a function call on a class, just like we would on any other thing. And we want to pass in a number. So we want to start with 0 because 0 is the first slot in the array, and we want to end with however long the array is. We could say 3, but then if we decide later on to go in here and add some names like Jimmy and Joseph, now all of a sudden that this isn't good. And if we've done this 1,000 times in our code, then that means we have to go through and change it 1,000 times, or it won't work in any of those instances. So what's a better thing to do is to type names.length. What that is that's the length of the array. So however many slots there are, there's 1, 2, 3, 4, 5 slots. Now, you might be saying to yourself, but wait a second, you just got done telling us that programming counts from 0. You're right, it kind of does. This is slot 0, but as far as the number of slots, there are 5. So that's really, really inconsistent, but that's my theory as to why random range doesn't include the maximum, is so that you can use things like names.length, and it doesn't include that higher value, which doesn't exist. Slot 5 doesn't exist here. 0, 1, 2, 3, 4. 5 doesn't exist. So you can use names.length as your maximum for the top range and still have it work without throwing any errors ever. I feel like it's a really loose explanation as to why, and I don't think it holds water, but that's my theory. I don't know if it is or not that way. Anyway, so random range between 0 and the length of the array will give us a random name between here, and we can see that when we run the function, or run the game every time. So this time it gave us Jimmy. Next time it's going to give us Jeff. This time it gives us Jimmy again. And this time it gives us Joe. So every time it's different. Well, maybe. But anyway, that's kind of how to use random and how to access the different slots of an array. The other thing you can do is you can say, I'm going to go ahead and delete all this stuff and make that array public. And you'll understand why in just a second. Now, if we say names random.range and we feed it a 0 and names.length, so we're accessing a random slot in the array, we can say that array equals selected. If I can spell it right. There we go. So what we're going to see when we go back into Unity when it updates is we have this list of names, and then when we start the game, number 2 went to selected, and if we started again, number 1 went to selected, and if we started again, number 2 went back to selected. If we started again, number 2, it should choose a different one eventually. There we go, number 3. So what this is saying is choose a random name and set it to selected. So that's an easy way to, that's an example of how to set the different values in an array as well, if you have something that you wanted to set. And in the next video, I'll talk a little bit more about that. This is really weird because it's the video I already recorded, but you get the idea. So that's how you would do that. And using random numbers is really, really great for that. And actually, most of the time you access a random slot in an array, or most of the time you want to use a random range, you're usually looking for an array or a percentage, which is why the float is inclusive and the int is exclusive, is because those are the two things you want to do the most, and it helps support that, I guess. That's what I was trying to say with, I think that's my theory, but I don't know. Anyway, so the other thing you could do is you could use arrays with loops, and this is another thing that's really, really useful. So if we do our old for loop, we make an int I equals 0 and I less than names.length, because we want to go through each slot in the array and iterate it. Then we already made our close. So if we have this array, this loop here, we're going to go through each slot of our array, and we're going to debug.log each slot in the array. Oh, I have 2 curly brackets there. That's why that was being weird. All right, so names slot I. So what this is going to do is it's going to step through each slot in the array, and it's going to print off the name to our console. We will see that here. So Joe, Jeff, Jimmy, or Jeremy, Jimmy, and Joseph. So just like what we have over here. So what we did there was we have our int, and we said for as long as I is less than the length, because we don't want it to be the length, because again the length is going to be 5, or 1, 2, 3, 4, 5. The length is going to be 5, which is going to be that slot that doesn't exist. 1 slot passed. We only want it to go to 4, 1 less than the length. So we don't want it to be less than or equal to the length. We just want it to be less than the length. Hopefully that makes some sort of sense. But that's also from the last video. So yeah, this goes through and prints off everything in the array, and that's how to use arrays and loops. Likewise, if we wanted to say string more names equals a new string here, and we wanted to say this is going to be Kathy Carrie Karen Kathleen. So we have this private string down here and this public string up here. So we won't be able to see this one, but we will be able to see that one. If we set names to more names, what we're going to see when the game starts is that this list over here changes to our K names instead. So it's what this is saying is names becomes more names. So whatever we originally had in names, so this Joe, Jeff, Jeremy, Jimmy, Joseph, is thrown away. We're not going to use it anymore. There's nowhere to access that data anymore because it's gone. But now we have two different arrays, two different lists with the same data. So if I make that public as well, we will see that more names appears. Ooh. And they're both the same now. If we wanted to, say, swap the two, the best way to do that would be to, say, create an intermediate array that then holds the data for that. So we can say temp equals names. So that's going to be a new list of names that is the same as names. So it's a duplicate, essentially. And then names is going to equal more names, and then more names is going to equal temp. And what this will do is it'll swap the two. So once we start the scene here, we will see them switch. So that's some handy like array tips and tricks, I guess. I don't know. A lot of that stuff will become second nature to you if you keep on programming and keep on with it. But I hope that was at least helpful on understanding what arrays are and how to use them a little. The next video I'll be talking about, and I have already talked about, I guess, which is weird, an example that I wrote that uses arrays in a runtime script. So it uses it's keeping with that carnival theme. It's kind of like a roster of the people that are in the carnival. So it's people enter, people leave, and there's like random chances, and there's percentages, and adding and removing things from an array, which is tricky, and looping through things and printing out data. It's a lot more interesting than this was, and it's the first script in the tutorial where I actually do something during runtime. So that's exciting if you've never seen anything like that before. But I think that's it for now, and thanks for watching. Bye-bye.